Hello class, my name is Miss Cortez. Today we're going to be talking about the Pythagorean theorem. So our mathematical goals for today include helping students to understand how to use Sketchpad to construct right triangles and use the measurement features to better understand the Pythagorean theorem. Also having to do with how squares are related to the Pythagorean theorem. And our technology goals are to teach students how to make constructions of triangles and squares using GSP, as well as the measurement features of GSP. So in previous lessons, we have actually already learned how to construct right triangles and squares using GSP. And so in the actual lesson itself, I've created some more of these hide and show boxes that are going to help us so that we don't spend so much time in this video going over it. But if students had questions because they forgot how to do it, I would be happy to go over how to make or construct right triangles and squares again. The squares are actually, we are able to use these tools that are already prepared for us. We have this square given two vertices tool that we used in this video. If anybody has questions on doing the construction of right triangles, I'd be happy to go over it again at the end of the lesson for students who don't fully understand what is going on. So our pedagogical and content knowledge goals have to do with how students in just every classroom practically there's a few students at least that don't understand what a formula really is for. They just know, oh, I use this formula and it does this. But they don't understand why that formula works. And so our goal today is to have students actually understand the reasoning behind the Pythagorean theorem and why it works. And during this lesson, I would ask students questions like, why do we use squares to help understand the Pythagorean theorem? And why is it important to know the Pythagorean theorem? Also, I would have students construct what I'm constructing in the video on their own computers. I would actually have them do this after I went over the lesson because I wouldn't want them to be too distracted in trying to help each other. I wouldn't want them to get stuck and frustrated if they couldn't figure something out. I would want them to first watch this lesson, and understand what I'm doing, and then if they had questions when they're doing their own constructions afterwards, then I would go around and be able to help them without distracting from the lesson itself. So we're going to jump to this lesson. As I said before, I already constructed right triangle for us so that we could kind of jump ahead and not spend too much time doing it in the actual lesson. So here's our right triangle. We can do the drag test to confirm that this really is a right triangle. So everything looks good. So, like I said before, we would use this tool down here to construct squares on the three sides of this triangle. I've actually already done that for us, so I'm just going to show these squares. Ooh, it's a little bit big. We're going to make that a little bit smaller. Okay, so here are the three squares that we're going to be looking at. So what we actually are interested in these squares is what their areas are. And so the area of a square is its length squared, or you could think of it as the length times width, but really it's just the length squared because all sides of a square are equal. And so I actually found the areas of all three of these squares for us using the calculator feature up here. Oh, sorry, and under number calculate. So I already used the calculator. I'm just going to show what our area measurements are. Oh, I'm sorry, I didn't use the calculator for that. I used the measurement feature to find the areas. But I did use the calculator to find what the sum of the two smaller squares are because we want to compare that to what the sum of the largest square is. So I'm going to show the sum of the two smaller squares. And as we can see right now, the sum of the two smaller squares is equal to the sum of the largest square. So we're going to play around with this a little bit to see if that's still true if we change the lengths of the sides. And so we are moving it around, and you can kind of see, no matter how I move it, that the sum of the smaller area, or the sum of the area of the smaller squares is still equal to the sum of the area of, the area of the largest square. So we know that they are always going to be equal to each other based on this, and so we're going to look at our definition of the Pythagorean theorem. And it says that the square of the length of the hypotenuse of a right triangle, which is the longest side, is equal to the sum of the squares of the lengths of the other two sides. And so, like, in a formula, this is known as a squared plus b squared is equal to c squared, where a and b are the lengths of the two shorter sides of the triangle, which is the opposite and the adjacent sides, and c is the length of the longest side, which is the hypotenuse. So earlier in this lesson, I was talking about, like, why are squares important when understanding the Pythagorean theorem? It's because in the formula, we see that it's a squared plus b squared is c squared, which is actually a squared is the length of, or is the area of either one of these squares, whichever one you want to call a and whichever one you want to call b. So this is actually, we're looking at the areas of these triangles in relation to the lengths of the sides of this, the area of the squares in relation to the sides of the triangle. So that's why squares are important when we're dealing with the Pythagorean theorem. And also, why is the Pythagorean theorem important? Well, it allows us to find the length of a missing side of a triangle. So say we know what A and B is, but we don't know what C is. We can use this formula to find out what that third length of the triangle is. And so hopefully this has given students a better understanding of actually what the Pythagorean theorem is doing. And hopefully it will, like, if there's any questions, I can answer them later if any students have any more questions. So anyway, I hope this was helpful, and have a great day, guys.